Installing a 110 volts power supply to a relay box inside a bathroom cabinet is generally against electrical code. The National Electrical Code (NEC) prioritizes safety by minimizing electrical shock and fire risks. NEC Article 427.4 mandates that enclosed switches or circuit breakers must be in readily accessible locations. Bathrooms are classified as wet locations, triggering specific requirements for electrical equipment. NEC Article 410.4 states that electrical equipment in wet locations should be protected from moisture. Cabinets are viewed as enclosed spaces that can trap moisture. Introducing 110 volts power into a bathroom cabinet poses a safety hazard, as moisture can harm equipment or cause electrical shock. To adhere to the code, install the relay box in an accessible area outside the cabinet. Consider using a junction box or electrical panel inside or just outside the bathroom. Ensure the relay box is rated for wet locations. Properly install and protect all electrical wiring from moisture. Properly ground the relay box to avoid electrical shock. Local code requirements can differ. Consult a qualified electrician for correct installation and compliance. The NEC addresses these safety concerns with specific articles. NEC Article 427.4 focuses on accessibility, stating enclosed switches or circuit breakers must be readily accessible. This accessibility is crucial for maintenance, inspection, and emergency situations. Placing electrical components inside enclosed cabinets restricts access and violates this code. Bathrooms are classified as wet locations. This classification triggers additional safety measures to protect against moisture-related hazards. Article 410.4 of the NEC is particularly relevant. It emphasizes that electrical equipment in wet locations must be installed in a way that prevents moisture from affecting its performance or safety. Cabinets, being enclosed spaces, can trap moisture from showers, sinks, and general humidity. This trapped moisture can condense on electrical components, potentially causing corrosion, short circuits, and electrical shocks. To ensure compliance and safety, install the relay box outside the cabinet. A junction box or electrical panel located in a bathroom or in an adjacent dryer room offers a suitable alternative. This placement ensures the relay box is accessible and less susceptible to moisture damage. Firstly, the chosen relay box must be specifically rated for wet locations. These ratings, typically indicated by NEMA or IP ratings, ensure the enclosure can withstand moisture without compromising safety or functionality. Secondly, all electrical wiring must be installed with moisture protection in mind. Use appropriate conduit, waterproof connectors, and ensure proper sealing to prevent moisture ingress. Thirdly, proper grounding is essential to prevent electrical shock. The relay box and all associated wiring must be grounded according to NEC guidelines, providing a safe path for fault currents. The NEC provides detailed specifications for grounding methods and materials. Local electrical codes can vary depending on the specific jurisdiction. Always consult a qualified electrician who is familiar with local regulations to ensure compliance. The electrician can provide guidance on the specific requirements for your location and ensure that the installation meets all applicable safety standards. Installing electrical equipment in bathrooms requires careful consideration of moisture, accessibility, and safety. By adhering to the NEC guidelines and consulting with a qualified electrician, you can ensure a safe and compliant installation. Remember to prioritize safety and always seek professional advice when dealing with electrical work. The NEC provides the framework for safe electrical installations, and understanding its requirements is essential for protecting yourself and others from electrical hazards. Firstly, confirm the voltage requirements of the electric floor heating system. Ensure the relay box is compatible with both the input voltage from the power source and the output voltage required by the heating system. Secondly, calculate the current draw of the floor heating system. Select a relay box with an appropriate current rating to handle the load without overheating or failing. Thirdly, verify the relay box is listed by a recognized testing laboratory, such as Underwriters Laboratories or ETL Semco. This listing indicates the product has been tested and meets safety standards. Fourthly, ensure the relay box enclosure is suitable for the bathroom environment. A NEMA 3R or higher rating provides protection against splashing water and humidity. Fifthly, use appropriate wiring methods for connecting the power source, relay box, and floor heating system. Follow NEC guidelines for wire gauge, insulation type, and conduit requirements. Sixthly, install overcurrent protection, such as a circuit breaker or fuse, in the circuit supplying power to the relay box. This protection will prevent damage to the system in the event of a short circuit or overload. Seventhly, properly ground the relay box and all associated equipment. Grounding provides a path for fault current to flow back to the source, reducing the risk of electrical shock. Eighthly, label the relay box clearly to indicate its function and voltage rating. This labeling will help prevent accidental contact with energized parts. Ninthly, test the installation after completion to ensure it is working properly and safely. Use a multimeter to verify voltage and current levels. Tenthly, consult with a qualified electrician to review the installation and ensure compliance with all applicable electrical codes and regulations. An electrician can identify potential hazards and recommend corrective actions. The NEC defines specific requirements for electrical installations in wet locations, such as bathrooms, to minimize the risk of electrical shock and fire. The code mandates the use of ground fault circuit interrupters, GFCIs, for receptacles located in bathrooms. GFCIs detect imbalances in current flow and quickly disconnect power to prevent electrical shock. The NEC also specifies the minimum clearances for electrical equipment from water sources, such as sinks and showers. These clearances help prevent water from coming into contact with electrical components. The NEC requires all electrical wiring to be protected from physical damage. This protection can be achieved through the use of conduit raceways or other approved methods. The NEC provides detailed specifications for grounding electrical systems. Proper grounding ensures that fault currents can safely flow back to the source, reducing the risk of electrical shock. The NEC requires all electrical equipment to be listed by a recognized testing laboratory. This listing indicates that the equipment has been tested and meets safety standards. The NEC provides specific requirements for the installation of electric floor heating systems. These requirements address issues such as wiring methods, overcurrent protection, and temperature control. In addition to the NEC, local electrical codes may impose additional requirements for electrical installations. It is important to consult with a qualified electrician to ensure compliance with all applicable codes. Cabinets can trap moisture, leading to corrosion of electrical components. Corrosion can cause short circuits and increase the risk of electrical shock. Cabinets can restrict airflow, causing electrical equipment to overheat. Overheating can damage equipment and increase the risk of fire. Cabinets can make it difficult to access electrical equipment for maintenance and repairs. Inaccessible equipment can be neglected, leading to safety hazards. Cabinets can create a cluttered environment, making it difficult to identify and troubleshoot electrical problems. A cluttered environment can increase the risk of accidents. Installing the relay box outside the cabinet ensures it is readily accessible for maintenance and repairs. Regular maintenance can help prevent safety hazards. Installing the relay box outside the cabinet allows for better airflow, preventing overheating. Preventing overheating can extend the life of the equipment. Installing the relay box outside the cabinet reduces the risk of moisture damage. Protecting the equipment from moisture can prevent corrosion and electrical shock. Installing the relay box outside the cabinet creates a safer and more organized electrical installation. A safe installation protects occupants from electrical hazards. Firstly, review the manufacturer's instructions for the electric floor heating system. The instructions may provide specific guidance on the placement of the relay box. Secondly, determine the location of the power source and the floor heating system. Choose a location for the relay box that is convenient to both. Thirdly, consider the accessibility of the relay box for maintenance and repairs. Choose a location that is easy to reach. Fourthly, consider the environmental conditions at the chosen location. Avoid locations that are exposed to moisture or extreme temperatures. Fifthly, ensure the chosen location meets all applicable electrical codes and regulations. Consult with a qualified electrician to verify compliance. Sixthly, mount the relay box securely to a wall or other suitable surface. Ensure the mounting method is appropriate for the weight of the box. Seventhly, connect the wiring to the relay box according to the manufacturer's instructions and NEC guidelines. Use appropriate wiring methods and connectors. Eighthly, test the installation after completion to ensure it is working properly and safely. Use a multimeter to verify voltage and current levels. Ninthly, label the relay box clearly to indicate its function and voltage rating. This labeling will help prevent accidental contact with energized parts. Tenthly, keep the area around the relay box clear of obstructions to allow for easy access. An unobstructed area makes maintenance and repairs easier. By following these steps, you can select a safe and compliant location for the relay box. Remember to prioritize safety and consult with a qualified electrician if you have any questions. The NEC specifies that electrical equipment in wet locations must be installed in a manner that protects it from the effects of moisture. This protection can be achieved through the use of enclosures, sealants, and other approved methods. The NEC requires all electrical wiring to be installed in a neat and workmanlike manner. This requirement ensures that the wiring is properly supported and protected from physical damage. The NEC provides detailed specifications for grounding electrical systems. Proper grounding ensures that fault currents can safely flow back to the source, reducing the risk of electrical shock. The NEC requires all electrical equipment to be listed by a recognized testing laboratory. This listing indicates that the equipment has been tested and meets safety standards. The NEC provides specific requirements for the installation of electric floor heating systems. These requirements address issues such as wiring methods, overcurrent protection, and temperature control. In addition to the NEC, local electrical codes may impose additional requirements for electrical installations. It is important to consult with a qualified electrician to ensure compliance with all applicable codes. A wet location is defined as an area that is subject to saturation with water or other liquids. Bathrooms, kitchens, and outdoor areas are typically considered wet locations. Electrical equipment in wet locations must be protected from the effects of moisture to prevent electrical shock and fire. The NEC provides specific requirements for the installation of electrical equipment in wet locations. These requirements are designed to ensure the safety of occupants and property. A qualified electrician can assess the environmental conditions at your location and recommend appropriate measures to protect electrical equipment from moisture. Consulting with an electrician can help ensure that your electrical installation is safe and compliant with all applicable codes. Firstly, choose a location that is not directly exposed to water. Avoid installing the relay box directly above a sink or shower. Secondly, use a relay box that is rated for wet locations. An NEMA 3R or higher rating provides protection against splashing water and humidity. Thirdly, use waterproof connectors and fittings to connect the wiring to the relay box. This will prevent moisture from entering the box. Fourthly, seal any openings in the relay box with silicone caulk or other approved sealant. This will prevent moisture from entering the box. Fifthly, install a drip loop in the wiring entering the relay box. This will prevent water from running down the wiring and into the box. Sixthly, ensure the relay box is properly grounded. Grounding provides a path for fault current to flow back to the source, reducing the risk of electrical shock. Seventhly, inspect the relay box regularly for signs of moisture damage. If you find any damage, repair it immediately. Eighthly, consider installing a ground fault circuit interrupter (GFCI) in the circuit supplying power to the relay box. A GFCI will detect imbalances in current flow and quickly disconnect power to prevent electrical shock. Ninthly, consult with a qualified electrician if you have any questions about installing electrical equipment in wet locations. An electrician can provide guidance on the specific requirements for your location. Tenthly, remember that safety is always the top priority when working with electricity. Take all necessary precautions to protect yourself from electrical shock. By following these steps, you can protect your electrical equipment from moisture and ensure safe installation. The NEC provides detailed specifications for electrical installations in wet locations. These specifications are designed to protect occupants and property from electrical hazards. A qualified electrician can help you understand and comply with these specifications. Installing a relay box in a bathroom requires careful consideration of the environmental conditions and the applicable electrical codes. By following the guidelines outlined above, you can ensure a safe and compliant installation. Always prioritize safety and consult with a qualified electrician if you have any questions.